So we'll have our original system, in this case 2x plus 3y equals 7, and x minus y equals 1. Then we'll convert it to a new system where we replace one equation with a sum of a multiple of that first equation and the other. And then we'll use it to get our solutions. So we use this as our structure. Okay, let's look at this one. I always get to pick which variable I want to get rid of. There's no preference one for the other. Let's go ahead and try to work with y's, okay? So if I want to create an equation that only has y's in it, or that has no y's in it, if that's what I want to eliminate, here we have our equation 1, equation 2. Then the question I'm asking myself is, what multiple of the second equation would I add to the first in order to get rid of the y's? So I see a 3y in the first equation, so I know I need to add a negative 3y term. And if I look at my second equation, I can make it, we can get the negative 3y we would need to cancel out. So we can multiply a2 times 3 to get an equation that can cancel the y's in equation 1. And by cancel, I mean I can add it to the first equation and cancel, and it will eliminate all my y's. So let's write that down. What would that be? So 3 times a2, we're talking about 3 times x minus y equals 3 times 1. 3x minus 3y equals 3. So I'm going to take that and I'm going to add it to my original a1. So there's my 3a2 and I'm going to add it to my original a1. a1 was 2x plus 3y equals 7. Okay. Now we can just add vertically 10. I'm moving right to left for some reason. The negative 3y and the positive 3y cancel, and the 3x and the 2x give me 5x. So there's my new system. My second equation is going to be 5x equals 10. You also could pick actually to save whichever one you want. Let's go ahead this time and let's go ahead and replace this. We'll call this our new B1. We'll call this equation B1. And let's replace the first equation because it does make the math a little faster. So equation B1 will be 5x equals 10, and equation B2 will be coming straight from the old A2. So it'll be x minus y equals 1. So go ahead and solve that 5x minus 10, or 5x equals 10. So now let's solve the one that's simple to solve. 5x equals 10, we get x equals 2. And replacing that in equation B2, we get 2 minus y equals 1. So I'm going to subtract 2 from both sides, and negative y equals negative 1. And then that means that y is 1. So y is 1, x is 2. The final answer we're going to write as an ordered pair, 2, 1. So let's write down the steps that we're using in these problems. I'm going to shrink this in a little so we can see it with the steps. Determine which variable in which equation you want to eliminate first. Sometimes this is an easy choice if adding the two equations together or directly subtracting them will immediately cancel one of the variables. It does tend to be easiest to do this by using the equation if they don't have something in common, using the equation where you already have a coefficient on both terms. Then you're going to multiply the other equation by a constant that makes the coefficients on the two equations equal or opposites. It doesn't matter which way you think about it. So as an example, if equation 1 has negative 5y, you multiply equation 2 by something so that it has negative 5y, or positive 5y if you want to do adding. The third step is to add or subtract the two equations to get a new equation to replace equation 1 that only has one variable. And I wrote add/subtract because some students really like to always think of it as making it so that the coefficients are exactly the same in the two equations. So if one of them had a positive 5y, they're going to do whatever they have to make the second equation have a positive 5y, and then they subtract the two. Other students find it's more helpful to them to multiply the second equation by something that makes it so that it will exactly cancel out what we see in the top one. So they don't have to think of it as subtraction, but adding a negative. And then they add the equations. And those are equivalent processes. Step 4, solve the one variable equation. Step 5, use the solution for the one variable to get the other coordinate. And we're going to do that by substituting into the other equation from the new system. Step 6, write your final answer as an ordered pair. And be sure to check. It's very easy when you're doing this to accidentally drop a plus or a minus.